Hi, this is Steve Bonacontri from SOA Consulting Services, continuing our Angular 4 tutorial series. Today we're going to talk about intercomponent communication. An Angular application is a tree of components. The component design goals include reusability, self-containment, and the goal to provide loosely coupled communication mechanism. I'll just point out that what you'll see in Angular component templates is the communication typically is defined using directives and annotations, and most of the communication does appear to be interpreted through the templates. So keep that in mind. There's several communication mechanisms. You got parent to child, you've got child to parent, and when two adjacent components, let's say, want to communicate with each other, one component can communicate to a mediator, and that mediator can communicate back to the component. Now, Angular does provide change detection, so a lot of this stuff happens automatically behind the scenes. However, you do have to provide the mechanisms in which it happens, like annotations, directives, etc. So to pictorially represent intercomponent communication, you can view, your view basically consists of components that need to communicate with each other in a loosely coupled fashion. The least each component knows about each other, the better. So you use binding and events for components to communicate with each other. And when you look at the view, you basically look at the markup fragments and you think about the components that make up the markup. And like I said, we're really just thinking about component templates here, and when we look at this picture, think of certain state, which is, let's say, in component 4 and not shared necessarily with component 5, or the web page or the Angular application root application component number 1 has data, and component 7, 8, or 3 cannot access it necessarily. But you do want to share data when needed, and you do want the component templates to be able to communicate with each other. So that's what we'll be discussing. So when you look at a root application, let's say component number 1, it can be viewed as a container, a parent container of, let's say, component number 2. Component number 2 could have a child 4, and component 2 can be viewed as a container for component number 4. And the components have peers, of course. 7 is a peer with 8, but 7 and 8 are both contained within a container, component number 3. So when you do design and component architecture and development, you basically think about these things, and you try to write reusable components in such a way that component 4 does not need to know about the implementation of component 5, etc. Okay, so let's look at the first form of communication, parent-to-child communication. Parent components can send data to its child by binding to the input properties of the child. So basically, if you look at what I have here is a representation of a browser and a parent template, let's say, which corresponds to a root component. So we have a parent component template, and that is made up of a parent tag. The parent tag basically tells Angular to render this application so the user can interact with it. And then you also could have a child component, which has a corresponding child template. And the child component, we say, is a child of the parent because the template is basically a child of the parent template. So basically, what I'm representing here is the component templates and their relationship between the backing objects and the front end template. And but all of this is running in a browser. It's all JavaScript code. So these objects on the right hand side are objects running in the browser. So I'm just trying to project them to the right here so we have a closer look to see what's going on. The parent component could have a price attribute. And if you change the price in this component, the parent template, Angular tries to render that new value in the template. And that particular value, when the price changes in the parent, can be mapped to the cost attribute of a child via an input annotation. So our job is to use annotations like at input to say, well, I'm going to pass a parameter, a dynamic value of a parent attribute to the child component using these directives. Okay. Keep in mind that Angular and all of its libraries and packages, etc., are implementing the change detection. So when we change the price value, and then this value changes, it's dynamically propagated through this cost attribute of the child component. So first, change price to price changes in parent, then cost inside child component changes. So, like I said, when you're looking at parent to child communication, you're trying to define the loose coupling of the components, and one way to do that would be through the template. So now it's good to understand the software development. It's good to understand the life cycle of these components, because as price changes, this value changes, this value changes, this value changes, and all of it has to do with the life cycle of the component templates and how Angular is changing the data, so the change detection is propagating in the application. But let's face it, our job is to produce something in production that works, and bottom line is, as far as what I'm describing here, is what you need to know in order to pass data from a parent to a child. Okay, so now let's look at child to parent communication. Child components can send data to parent by emitting events with output payload. So let's take a look at this particular situation. We have a child component. We have an annotation which says at output. You have a cost, which is of type event emitter. And what you do with the cost is you emit events. And the change detection says, okay, when cost changes, it'll emit the event. And the event comes up into the child template. So cost here, number 2, when cost event data is emitted, it triggers the parent event handler. The parent event handler says, invoke the price handler. Price handler is in the parent. So the parent handles the event data, and the parent's attributes, let's say the price, could then be changed by the price handler. Okay, so you could do both of these communication mechanisms at once. I have a little example which does that. and we'll take a look at that later. Now, I have a statement here. Presently, there's no event bubbling. I guess I should take a look at Angular 4 to see what's really there, but it probably is no event bubbling, and that is the parent template can't intercept this event. Let's move on. Okay, so I made the statement, there is no event bubbling supported in Angular. That is, the event can only get caught by the child template. Okay, so in the child component, number one, you can emit the event data. When the course event data is emitted, if it's not handled by the child component, it will never be seen by the parent component. Okay, so we talk about component outlets. At input is an annotation used to define attributes that will receive values from the outside world. You bind produces of these values to the corresponding inputs of the component. At output, that's a capital O, of course, annotation used to define attributes that will be used to communicate with the outside world by emitting events. Receivers listen or subscribe to the events. Okay, so then we should talk about the mediator design pattern communication. Defines how a set of objects interact. Although each component must be self-contained and not rely on the existence of other components, mediators can be used to help them interact. So number one, the mediator for 4, 5, and 6 components. Number 2 can be a mediator for 4 and 5 components. That is, component number 4 can pass data to its parent container, and that parent container can pass data to its child number 5 component. And number 3 mediator can be used for 7 and 8 components. Now, we want these components to be self-contained, reusable, etc. So we do this with, I'm going to say, component wiring. But keep in mind that once you bind this data using directives and annotations, well, mostly the directives, you do get some sort of a binding, coupling with the attribute names, etc. So I like to keep the attribute names unique in the component, and I might mix it up a little bit just because I want to ensure you that our coupling really isn't a tight coupling. It is a loose coupling, but certainly unlike older versions of Angular where I would just use a service to share data among an application or use parent scope or root application scope to store common data. It's discouraged in component architecture because you want the components to be self-contained and reusable, and you want to follow best practices. Okay, so let's look at mediating communications. A mediator uses well-defined, loosely coupled components and orchestrates tasks needed. So, for example, a price quota component can output an event data. An app component can receive that data and bind it to an order component using the input annotation. Okay, let's talk about projection. Using the ng content directive, we can project a fragment of the parent's component template onto its child. That is changing a template at runtime. Okay, so if we have a parent template which has a child tag, and we have a div with a string in it, let's say pass to child, and we have a child template which has an ng content tag in it, that div which says pass to child will be passed to the child template. We call that projecting the div content onto the child template. Now what we'll see in our example as we discuss some examples of doing this is you'll see how we use Shadow DOM with styles. And we look at view encapsulation of none, emulated, etc. And what you'll see is even though you're projecting the div content onto the child template, the style of the parent component template governs that projected content. So it's interesting to look at that and understand what's going on there. Okay, you can do projection into multiple areas as well. Using the ng content directive, we can project multiple fragments of the parent's component template onto its child in multiple areas. So suppose you have a parent template. We have one div which says this content is defined in the parent template. And you have a child which has two div tags. One has a class header, one has a class footer. Well, you can construct a child template with an ng content and use the select to define where we're projecting the header div class from the parent into the child. You could also select a .footer and determine where the div element with the class footer is being injected into the child. So when we look at this result, you'll see the child template with the header div tag, the child div tag, and the footer div tag. And like I said, once again, you have the Shadow DOM creating different DOM elements to control the scope of your styles in your child component template, in your parent component template, in your web application, so you can control the styles of these different projected markup fragments. Okay, so the component lifecycle is important to understand. And loosely speaking, you want to try to understand simple, important aspects of the lifecycle first. The component is created using the constructor. It's initialized. Its at input properties are propagated. Its ng on changes function is invoked to initialize state only if the parent modifies the input properties. And then ng on init executes. So then the component is added to the DOM, it's rendered, and then as changes occur, change detection occurs, and of course the at input properties take effect and the ng on changes method gets invoked again. And then eventually you destroy your component. Let's say when you move out of a route or something and the component goes away. So now keep in mind that the application, the Angular application, is a tree of components. So this gets a little bit confusing when you start introducing even as simple as a parent and a child component. We took a look at that in some of our examples of what happens. But take one example, just take one component, use Angular CLI, generate an app component, and look at the look at the ng on init method, then introduce a child component, use an at input annotation on it, overload some of these functions, and take a look at the order in which they execute. It's really important to understand that, and very hard to remember, by the way. But that's why I'm keeping it really simple here. The constructor creates the object and initializes to some extent. The at input properties take effect to initialize any input. The ng on changes will execute if the parent has modified the input properties, and then the ng on init happens. And then the object is added to the DOM. So we went through this before. You can in your constructor, you keep it light. You could even use, you might initialize some things that are very quick, and then ng on init is used to call web services to initialize more state, etc. Okay, so here's a detailed breakdown of the component lifecycle. Like I said, the constructor happens, the ng on changes or do check happens, ng on init happens, and then you have this ng after content init. This is invoked when the child component state is initialized if you use the ng content directive to pass some HTML code to it. So think of all the ng after contents as the projection lifecycle methods. The ng after content is checked is invoked on the child component that use the ng content after it gets content from the parent or during the change detection phase if the bindings used in ng content change. Then you have an ng after view init. This is invoked when binding of a component's template is complete. The parent component is initialized first, and if it has children, this callback is called after all children are ready. Then you have an ng after view checked. This is invoked when the change detection mechanism checks whether there are any changes in a component's template bindings. This callback may be called more than once as a result of modifications in this or other components. So like I said, the first ones that happen are the simplest ones, the more critical ones. The ng after content have to do with projection. The ng after view have to do with template reevaluations. And then, of course, you have your change detection, which invokes your ng on changes. So for ng on changes, as you have your, let's say, your at input annotation, if the parent changes its value and that change detection goes into that at input attribute, it gets passed into the child template, the ng on changes function gets invoked. And then, of course, you have your ng after content checked, because now that your value has changed, your content needs to be changed. And so there's some after content check methods which get invoked. And then after the component's destroyed, the ng on destroy gets invoked. So the ng on destroy is invoked when the component is removed from the DOM. That is router navigation or structural directive. if you're doing something like an ng if and the component's getting removed, that ng on destroy gets invoked. Mutable versus immutable. This is important. Why? Because change detection is related to things changing. And when I say things changing, you need to know what exactly is changing for there to be change detection occurring. So strings are immutable. If you have a var, greet equals hello, there's a memory location. If you change greet to hello Bob, the memory location changes. The value of greet changed. It now points to different addresses. But if you have an object like var user equals name Steve, you have a memory location associated with that. If you change user.name to Bill, the memory location is the same. But the memory location of Bill has changed. The memory location of the name has changed. So in this case here, it's important to understand that the object doesn't change. The attribute of the object changes. So just keep that in mind when you're looking at change detection. You should understand what is changing and what's not. So objects are mutable and strings are immutable. Change detection is implemented in the zone. They say in the zone. It's really zone.js. The purpose is to keep the changes in the component properties, the model, and the UI in sync, initiated by an asynchronous event that occurs in the browser. Let's say a user clicked a button or data received from a server, a script invoked a set timeout function, etc. Now keep in mind that the reason why we've waited for Angular for a long time is because that in the older version of Angular, this was not done right. It wasn't good for the implementation. The digest loop was not good for performance, etc. And so now they've re-engineered it, and things are implemented in the zone. The change detection is implemented in the zone, and so things perform much better. And we just have to understand change detection to the point where we could actually implement applications. So we have this concept of a cycle. Since a property changes in component, it checks all bindings in the component's template. The purpose, it applies changes from the component's properties to the UIs. Change detection never changes the property. An Angular app is a tree of components where the templates are compiled and each component gets its own change detector. Now there's different change detection strategies. You have a default, the zone checks the entire tree regardless of where the change happened. Or you have an on push. It checks the component and its children only if the bindings of the input properties have changed. So in the template, you can define the change detection strategy dot on push. That means check this component for changes and all the children under it only on push. And that should optimize your code so that your checking doesn't have to occur. Meaning, suppose I have a parent root component and I have a child component. I have my change detection strategy on push. That means my child component has a bunch of children, but nothing's going to change unless the parent gives me a new value of an @input property. And I'm going to define my change detection to be on push only because I'm going to claim that none of my children components of my child change, so don't check it and skip the change detection for my subtree to optimize performance. Okay, so change detection checks the parent component and all its descendants. The default strategy is even if there's a change in the parent, it goes down the tree, down the child, down the grandchild, and checks for all changes that occur and updates everything. Unless the bindings to input properties of the child component change, CD won't check the child or its descendants. So in a child, you could define the change detection strategy to be on push. And if there's a change in the parent component, the change detection will not check the child or grandchild because the on push strategy is being used. And be careful when you use this, because you could easily start changing templates and stuff, in which case you might need it. So just beware. Okay, so the large picture is this. You have an application. It has a parent. You have child 1, 2, and 3, grandchild 1, 2, and 3. And an event in the descendant triggers this change detection cycle, starting from the top. Child 2 and its descendants are excluded unless bindings to input properties of child 2 change. So notice, even if grandchild 1 has a change, the change detection goes from the parent all the way down the tree. It excludes anything that has an on-push strategy where that input to that particular child 2 has not changed. You could also expose a child component's API. Let's suppose you have a parent component with an H1 tag, and you have two children, @child1, not @child1, #child1 and #child2. You could find the child component identified by the template variable child1 and place the reference to this component into the first child variable. Using an annotation, viewChild, child1, you could define the first child attribute to be the child component. And then you could use this firstChild.greet child1, which means you're calling the greet function of child1. The parent's template accessed child component template 2. So what you can do in addition is you can have a button with a click event which calls child2 and invokes the greet function of child2 and passes in a child2 string to that function. And that will invoke greet on child2. So let's go over some examples now. The next tutorial will go through 4 different examples at least. We'll have one that's called communication. We'll look at binding input and output events. We have one called communication mediator, which uses the mediator pattern. We have one called communication ng content, which uses projection. And we have another one using a select, which uses projection on multiple parent elements that get projected into the child. Stay tuned for the next tutorial.